Hello, this is our video for the challenge number 2.
The objective is to prove experimentally the moment of inertia by obtaining the center of mass and measuring the oscillatory period with a physical pendulum.
Physical pendulum relations. Moments of inertia. The moment of inertia with respect to the origin is equal to the moment of inertia of the bar plus m times d squared, where m times d squared is equal to the mass times the distance of the center of mass to the origin. In the moment of inertia of the bar, A is equal to the length of the bar, while B is equal to the breadth of the bar.
The weight of our piece was 1 kilogram, 327 grams. When we substituted the different values, we were able to obtain the moment of inertia, which is equal to 0.7 kilograms meters squared.
We calculated the period by using the formula 2 pi times the square root of the moment of inertia over mass times gravity times the distance from the origin of the pendulum to the center of mass. We also realized that the mass is unnecessary, because the equation for the moment of inertia also has the mass, which cancels out in the division.
We used a universal stand in order to build our pendulum using an aluminum bar. This is our experiment, and we analyze it using video physics in order to obtain the time in a precise way. We set the x and y axis as well as the scale of our video, and then we set the points using the software. Finally, we obtain this graph, which shows that 1.9 seconds is the total time needed for a period to be completed.
To calculate the relative error, we simply subtract the results and divide them by the theoretic value.
The error between the experimental and theoretical calculation was due to the friction in the threaded tube and because the bar swayed itself along the axis.
The objective was completed, and we proved the properties of a pendulum experimentally and theoretically.